Hello, everyone. Today I'm, today I'm going to talk about inside Vitess and how you can use Vitess to have resilient distributed database. So about me, I'm Harshit Gangal. I've been engineer with PlanetScale, and I got introduced to Vitess when I was with Flipkart in 2016. From there on, I've been associated with the project, and I've been the core contributor and the maintainer for it. So today I'm going to talk about what is Vitess overview, what it is, what it delivers, and what are the different components of Vitess. And then we'll go into geo-sharding and the demo. So what is Vitess? Well, Vitess is distributed database solution built to scale out MySQL databases. Vitess is a CNCF project. It got graduated in 2019, and it has been open source with Apache 2.0 license. It is born out of the scaling issues at YouTube in 2010, and it was built on Borg. You can think Borg as like blueprint for Kubernetes, and it has been made to run on Borg from day one. So the resilience is already built in. So Vitess provides Kubernetes operator, and you can deploy and run Vitess in Kubernetes. It is massively scalable. Vitess has a lot of microservices, and you can scale out whatever you need as your application grows, and which part you want to scale out, you can decide, and then you have just microservices, you can scale out from there. It is highly available. So Vitess has like inbuilt health watchers, which actually keeps checking what is the current health, and if it sees your primary is going down, it can make sure that your primary is always available by doing the failovers. And Vitess is wire compatible with MySQL, so all the MySQL versions and flavors are just runs with Vitess. So I talked about what is Vitess. Now, why Vitess? So why would you choose to run Vitess? When anybody think about Vitess, they actually think about sharding as their first feature. But there is more to it. And we'll go into that, but let's talk about what are the problems you see when you run a single node MySQL, and then we'll talk how sharding can solve those problems. So first and foremost is write contention. You have so many writers writing on your machine, and then you hit the CPU limit or the memory limit. And suppose if you're running on cloud providers, you'll hit the IOPS limit. And then so many writers are writing that they try to acquire different kind of table locks, so you'll see deadlocks happening in your database, and that causes so much of write contention. Backup and restore time. So your data size is growing, and then you want to take backups for disaster recovery. But as your data size is growing, you will take more and more time to take backup. And same, when something really bad happens to your database, you want to recover, it again going to take a lot of time to even restore. Replication lag. So yes, you will see, oh, okay, my primary writes cannot scale, but let me scale out my reads. So you'll keep adding more and more replicas. And that is okay, you can scale out your read. But what happens is, because you're still writing too much, your throughput is too much on the write side, you'll see replication lags. And then also, once there's a replication lag, now the developers who are working on your applications and building features and flows now has to also now cater to problems like eventual consistency. And they have to deal with it in their workflows that, okay, if there can be some lag data, so how I should ensure that I'm not able to see lag data, and then they will try to work around it and do things around it. And then max instance size. You can continue scaling up, vertically scaling up and up. At some point, you'll hit the limits. And that's why you can't scale forever with single node. So once you perform sharding, a lot of these, or almost all of these problems will go away. Let's look at one by one how it really does. So once you do sharding, now you have multiple writers there. You have multiple disks there which are taking writes, and your write is now distributed. So your write contention goes away. Backup and restore time. In each shard, you can actually fix your data size. We recommend that you can do like 250 gigs, and as soon as you see it's going more than that, you can add more data and more like that. And what it does with 250 gig, why it's our recommendation, you can do whatever you feel like, but the recommendation is so that your recovery time is reduced to just 15 minutes. You can put it lower if you want lesser recovery time, but this is just a general recommendation. And replication lag. Now, because you have multiple writer nodes, write disk, so you're also now replicating parallelly. And what it ensures is that now, instead of replicating from one instance, now there are multiple instances, and each replica in that shard is just replicating from that particular instance. So you have less rights to replicate, and that's why your application lags get to minimal. The other way of looking at it, like a lot of users also do that, is that they have actually thrown away all their replicas. They have kept it for disaster recovery and failovers and stuff, but what they've done is now they're just reading from primaries. And if they see any contention, they just scale out. They just say, okay, let's add more shards and just scale out our traffic as it keeps growing. And yeah, maximum size, obviously, because now you can do horizontal sharding. You just keep reshards, and then you just get away with problems of hitting the size limits. So yeah, it solves all the problems that we mentioned, but can it run your operations? So besides sharding, Vitess is actually a full database platform. It can do automatic failovers. So we have VT.org, which actually ensures that it can handle your failovers. It ensures that whenever a primary goes down, it is able to promote one of the replica, and it can replicate, and that becomes the primary, and other replicas just join that primary and starts your cluster and ensure that it's available. And this is without any manual intervention. It has internally, the VT.org does everything, all the magic for you. Backup and recovery, right? So what Vitess does is it has a seamless backup and recovery flow. What happens that once you've taken a backup, and now you want to, so once you've taken a backup, and that too also you can configure, what it does is it's a pluggable store. So you can actually take backups to S3 or any other object store. And when you want to now take restore, so what you do is you just add a replica to that shard, and then that replica actually determines, okay, what is the last backup that I've taken, and then it recovers from that backup, and then it attaches itself to the current primary and starts the replication process. We have online schema changes. So as your data size grows, schema changes become a pain, and it's a very long running process. So what it does, so there are so many third-party tools available, PTOSC, Ghost, and other things. But Vitess inbuilt has a schema change mechanism that ensures that your schema changes are provided across all shards, and it uses a very powerful replication engine. So online schema change is just built in. Reshard. So there's a reshard workflows, which already are written in there. So you will see a near zero downtime whenever you want to do resharding when your data grows on a single shard. So let us talk about some more features. I just talk about how you can do, how it can run all your operations, but there are obviously more features, and then there are more features and more features. The list is just endless, but let's look at some of them more. Connection pooling. So Vitess actually multiplexes your client connections onto a fewer database connections. So what it does is it saves your resources, and your throughput just increases because you're using less resources at the very bottom. And at a higher level, you can actually just keep adding more and more applications that can connect to Vitess. Query consolidation, that's actually a very interesting feature. So what it does is, when you send multiple queries which are identical, what it does is it actually looks at what are if they can be merged together or not, and if they can be merged together, it sends only one query down to the underlying MySQL, which reduces the load on MySQL, but ultimately all the queries that have come will be served using that same query information. Global secondary index. So this is like a cross-shard index. So because now your data is distributed, and you will have something called shard keys. So what shard keys help is to tell that where my data should go and reside. But then sometimes your shard keys are not part of your queries. And what will happen? So in that case, you create a secondary index, which is on non-shard keys, which can map it to the right address where your data is residing. So global secondaries is available in Vitess. And then we have a support for cross-shard transactions. So Vitess has two-phase commit in built, and what it does is it makes sure that your multi-shard transactions are safe and reliable. And you can explore more by looking at the vitess.io website. So these are some of the subsets I've just taken. Yeah, it obviously works with all the frameworks and ORMs and the tools that already work with MySQL. So there are some of the notable companies which are already running in production. And you might not be realizing it, but there's so many apps that you use every day and they're already powered by Vitess. Vitess is just almost everywhere. And look at Slack. So every message that you send or read is actually stored and served by Vitess database. GitHub, you open a pull request, you write an issue, you comment on the issue, every activity is just backed by Vitess. Shopify, if you have actually shopped online on their Shopify store, it's been actually behind the scenes, Vitess is there. And there are new age companies actually, I've not mentioned here, but like Cursor. Cursor is actually using Vitess to scale fast and reliably. And then we have PlanetScale, which is offering its cloud database solution, which is powered by Vitess. So if you look at, as the companies scale right across the globe, there are new challenges that emerges. Not just handling massive data, but they have to also make sure that it is fast, compliant, and resilient everywhere. So that's where geo-sharding comes in. So let us go a little deep into why it's needed. So compliance, for sure, right? Even India has, the RBI rules are there that, oh, your data cannot move out if it's related to financial transactions. Then Europe has GDPR policies. So geo-sharding actually guarantees that your data residency is there by design. And latency. So obviously, like if your data is not residing close to you, then you will take a hit of the round trip time. So like a user in Hyderabad is now trying to access a US database. So you have to at least get a 300 milliseconds round trip time you'll see. So you don't want that. So you want your application to be fast and responsive. And scalability. So as your different regions grow, some will grow with a faster rate, some will go with a slower rate, and you want like, you don't want one global cluster to actually become uneven or overloaded. So geo-sharding helps you actually scale that particular region wherever you see that, okay, this is growing and it's becoming overloaded, so you can just scale out that independently. And resilience. So obviously, like you can have outages. Everybody has outages. And when you have outages, you don't want your whole app to go down. So if it's restricted to one region, then at least only that region's users are getting impacted and not the whole. So you boost availability of your app, which is running globally. So before we move on to the demo, I want to quickly go through the Vitess architecture. Basically, that will set a foundation to understand how actually sharding works. So, okay, this. Okay. So if you look at, I'll start with ground up. So if you look at, there is shards here. So in a shard, there is something called MySQLD, which is the instance that is running and holding your data. And then there is VT tablet. VT tablet is a sidecar. That is the only one that can talk to your MySQL. And that is the one that does connection pooling. It does much more, but we are talking only in terms of query serving paths. So let's think that VT tablet is here to ensure that all traffic goes through VT tablet. And then in a shard, you'll see there's a primary, and then you have multiple replicas. What VT tablet does is it exposes a gRPC API that the VT gate uses and sends queries using the gRPC API. VT gates are the one that is a user-facing component. That actually talks MySQL protocol. So all your application actually connects to VT gate. You can also have a load balancer in front to ensure that you are sending data to different VT gates and it's balanced, and so your data load is distributed across VT gates. But VT gates is the one where your application connects. So if you look at this query, let's talk about this query. It's a very simple query. I've just taken a very basic example to help you understand how things work behind the scene. So it's a select name from user where ID equals to 1. So what is happening is, once this query is sent by the user, we first parse this query. So after parsing, we generate an abstract syntax tree, so which tells us, okay, name is the output column that we need to know. User is the table that is involved. ID is the column which user want to filter on 1. So once that is there, what we do is we actually go for planning, but before planning, we normalize this query. So we don't know whether the user is asking for 1, 2, or 3, or anything. And that helps us in different cases. I'll tell you what it helps in. But once we does, then it goes for planning. And then if suppose ID is your sharding key. So what happens is in VT-Gate, once parsing is done, we go for planning. And then in the planning, what we do is there's a sharding scheme that the user has provided. So suppose for the user table, the sharding scheme used by is ID column, and user is sharding just by the ID column. So in the ID column, so what will happen is, now in the planning, we'll understand, okay, because ID is the sharding column, we know, and it is equal operation, so we know it's going to send only to one shard we have to send this query to. So the output of the plan will say it's a equal unique, and we are only going to send it to one shard, and then it goes for the execution, where the value is now provided outside, because it was normalized in the planning, but we keep it what the user sent. So we know that we have to send with the value 1, and so we map this value 1 to the right shard using the sharding function that we have. And once that is mapped, we'll get to know which shard it belongs to, and that's where the query will be sent down to VT tablet. So VT tablet will then send it to MySQL once we get a response that is being sent to the client. And then there are some other components, VTCTLD, which is the admin tool of Vitess. And then we have VTOrg, which I talked about, which helps you to repair your cluster. And then we have a VTadmin, which is the front-end UI, and also it can be used to manage the cluster. It indirectly calls VTCTLD APIs behind the scene. And then you have a topo server, which is etcd or Zookeeper, which helps you to store metadata, which is outside of the shards. It's separately stored and managed for storing your metadata and configuration of your cluster. So yeah, we'll go into the demo. I'll just show you. It's a very, very basic demo. And yeah, we have enough time. But yeah, so in respect of that, I create the demo very, very small and very, very restricted. And what it contains is that it has 4 shards. So here I've created 4 shards, which represent 4 regions. And these are belonging to different geographic regions. So that's why, like, if you look at the regions will be, one is Americas, Europe, APAC, and MEA. And the shard is -40 is for Americas, 80-40, 40-80 for Europe, APAC for ADC0, and MEA for C0- for MEA. So what this represents, these numbers, what it represents is the address space. So what is address space? -40 means is from 0 to 40, and it's like a hex. So you can think 40, and then there's so many zeros. And similarly, like if you look at C0-, what it's saying is hex of C0 till infinity. So that's how it covers the whole address space. And and here I'm just trying to show that, okay, like when we trying to insert data, that the data will only be residing in that specific geographic region, and it will give you like data residency for GDPR automatically. So the cluster is also already up and running, and if you look at here, there is cell called Americas, APAC, Europe, and MEA, and they are serving different shards. And this is a VT-Gate UI that's just showing that everything is just running and it's healthy. All the tablets are currently healthy. So yeah, if you, there was a QR code actually on the demo slide, which was trying to show that you can actually use that to see all the scripts that are there, and you can use it and you can play around with it. And then if there's any questions, we can take that in personally here or maybe in the Slack. Yeah. So if you look at here, there is a very basic customer table, which has something called the ID, and region ID that it belongs to, and then the country ID this customer belongs to, and then some email. And this is the sharding scheme that the user would have provided. And it's trying to tell that I am going to use country ID and the ID as my multi-column. So in Vitess, this term called, like you have indexes. In Vitess, we call it Windexes. Windexes are the one that is called the sharding key of a table. And that is what is used to determine where your data will reside. So over here, I'm using country ID, and country ID is using one of the hashing algorithms, binary, and the ID is using another hashing algorithm called hash. So what binary helps is like it takes, and what it's taking is first byte from binary. So when it hashes, it takes the first byte, and then it determines, okay, which that byte will live where, and then ID is there to, if you want future that you want to subshard your region, and then you can go and do subsharding, and that ID column will help you decide that where your, in subsharding, where your data will reside. So yeah. So this is some sample data that I have inserted into different regions and countries associated with it. Let's look at, yeah. So these are the 4 shard primaries that are there. And okay, oh yeah, I've not inserted. That was just showing the data. Okay, so now it's inserted. So if you look at, I think the first one is Americas, and then this is Europe, and on the left down is APEC, and then on the right is MEA. So if you look at the data is already going into different regions based on the sharding keys, and the data is being correctly sent to the right geographical region. It's just printing out like how, if you look at what countries are belonging to which region, that's what it's trying to show you. And that's what we saw, that how it's being sent to other places. Okay, so there are some queries that I'm sending, but what I want to actually show you is that they only go to the right region and not go to like any other region. So to do that, maybe I'll just quickly say continue, and then I'll show you the real queries that is happening. So this is the port that the VT gate is started on. So I'm just connecting to that port. And let me, yeah. So let's look at the plan first, just to help you see how it looks like, and then we'll execute the query as well. So this one actually contains both the keys, which are part of your sharding key. So because they both are there, it will be an equal unique plan, which means that it will only go to that specific shard. Yeah, that's cool, right? Like we know if you provide both, yeah, obviously you can just send it. It's very easy to route. But what interesting part is, if you remove this, then also it doesn't say it's going to do scatter, but what it's trying to tell you is it will go subshard, which means it will determine that, okay, because it's first part of the key, I can actually determine which is the range that I need to go in, and that's where it will go in and then execute your query. So that's what the power of using even multi-columns, that you can do subsharding, and here the country is determining which region it will go to, and only that region it will hit. And in fact, whenever you even don't know what your ID is. So you're only sending your query to the specific country that is holding your data. Okay, let's run the query as well. Let's run a APEC query, which is sending, which is equal unique query, but let's run it multiple times so that we can see on the graph that it is actually being sent to only one region and not multiple regions. So let's look at, yeah, I didn't show this, but let's look at this. So this is the APAC region and executed the APAC query, I think. Yeah, let's see if I executed the APAC query. So if you look at the blip of executing that query only happened here. So the query was only sent to the APAC region. And similarly, because still we don't have subshards yet in this example, even if I run, let's run this, only targeting a particular country. So this one is only targeting a particular country. Even if I run this, it will only go to Europe region and not anywhere else. So if you look at, this is the Europe region, and only it will go here and not anywhere else. So there's no traffic. This is the old traffic, not the new one. New one, there's nothing here. So while I was actually designing this, actually I thought about a little bit more, though it's not part of the demo yet. I was thinking that I can actually build, so what Vitess is very, very complex, but everything is very pluggable. So what thing is missing is, can I give region ID and can I only go to that specific region? Yes, you can do it. You have to write a lookup index, what we call. Basically what it does is it will use your region ID and then it will map it to a range. And once we have that range, it will actually send it. I'll probably upload follow-up on this on the same demo link. So let me go back. I'll put a follow-up lookup index on this if you go in, and there you can now play with only putting where region ID equals to 1, and you'll see that, okay, it's still going to only one specific region and it's not spreading out. So with that also, now even if you subshard that region, only that shards will be touched because you're giving region ID and it won't spread out to other regions. So that's how you will basically achieve some geo-sharding with Vitess. And then these are some of the resources. So we have a very good doc. Obviously, it needs improvement. Every doc needs improvement. It's very hard to keep up the pace of what the changes are coming in. So yeah, we are trying it. We have talked with CNCF. We are trying with CNCF people to get some docs, like getting them also involved and getting it to a better state. And we are working on it. And this is the Slack community. So if you're not able to catch me here, you can actually join the Slack community. If you don't have questions here, you can ask the questions there. And yeah, that's it. Thank you. Are there any questions? Yes. Sorry, I can't hear you.
Hello. Yeah. Thanks for the presentation. It was nice. I wanted to ask a bit about backups and restores. Do you support incremental backups, and also where does the backup go to? Do you like support?
So it's a pluggable implementation. You can do file store, you can do S3, you can do your NTFS, wherever you want to configure, you tell that. Mostly, a lot of plugins are already there. If it's not there, you can build one. And then there where the backup will start going.
Cool. And during restoration, for example, while the cluster is running and then we did something and it is in a non-recoverable state and we want to recover the cluster from a backup, do you support like in-place recovery, or like do you have to bootstrap a new cluster from the backup, or how does that work?
Yeah, you have to start a new replica, and that will restore. And once you have that you can use to Yeah. So once you are in a very bad state, suppose there is no primary, there is no replica, you have to get some backup, right? And you have to start with that. But if you have a primary and replica, and if your primary goes down, then the replica by default comes in and takes that place, and then you can bootstrap another replica because now the current primary is already become, like current replica already became primary. So your new replica then restores from the old last backup, and that will now attaches itself to the new primary, and then it will start serving your traffic.
Cool. One more thing is, do you also support snapshots, like volume snapshot? There's a snapshot controller, but do you support that?
So we do actually snapshot-based backups today.
Okay, cool. Thank
Yeah.
you.
Yeah. Any more questions? Yeah.
I have a use case for active deployment basically, so active model. So
Yeah.
there is no the database within that. So the data within that database is not like it is PII free, so I can replicate across multiple regions. So what I have problems is with collisions basically.
Correct.
When it is an active.
So that's why we don't want people to go into active-active. Why you want active-active? Just do sharding and let, and let your data stay in different zones. You can achieve same thing with primary and multiple replicas in different regions, which is still copying that, but your main writes go into that, because collisions is a very big problem with active-active, and I don't know why you like. I would really want to understand why you want active-active rather than doing
Like
primary and, yeah, sorry? High availability you still achieve because we have inbuilt modules which actually ensure that if your primary goes down, the replica will be promoted to a primary. But collisions are a very big problem. So you have to choose.
Absolutely, consistency over availability.
Yes.
you know.
And that's why we say you can actually shard wider. So even if your downtime is there, it will be for very minuscule, minute traffic. So it's not like it's across. So, yeah.
So what are the like replication lags for like between a like control plane, database which is acting for writes and the database which is actually used for in data plane for reads?
Can you repeat the question?
So let's assume that I have split my microservices into two parts, control plane and the data plane. Control plane to handle the modifications of the data, and the data plane just reads on it. So if we have such setup where one writes are going to one, let's say assume geo-distributed
Okay.
database, and if I want to have read replicas for them, so what will be the replication lag?
Right, so that's what it is. So if it's in the same availability zone, then it will be almost negligible replication lag. And if you're seeing it, so either you can relax your replication guarantees so that you can have faster one, or you can shard again so that now you have less load on each primaries, and then your application lag will improve. So that's the way you can solve it. And then if you're having a replica across different availability zone, then obviously there will be a replication lag because you have to get the cost of moving your data right from across different parts. So that will be there. So that will be an eventual consistency. But if you want high consistency, then you have to use the same availability zone for reading your data from replicas.
Thank you.
Yeah. All right. Thank you.